Okay, algebra students, this is the full video solution set for the first test of the spring semester. We'll start with number 1. Layla wants to purchase pencils and rulers for the students in her math class. If each pencil costs 10 cents and each ruler costs 50 cents, which linear inequality represents all the possible combinations of X pencils and Y rulers Layla can purchase if her spending limit is $25? Okay, this is one of those questions that it really helps to write as you read. So Layla wants to purchase pencils and rulers for her math class. So we could call pencils P and rulers R. And it says, if each pencil costs 10 cents, okay, so what we're going to do here is represent 10 cents as 0.1. The reason we're going to do that is because 0.1 as a percent would be 10%. And a dime, or 10 cents, is 10% of a dollar. So we're going to represent 10 cents as 0.1 times P. And then it says, and each ruler, so and plus, each ruler costs 50 cents. So here we're going to put 0.5 because 50 cents is half a dollar, or 50% of a dollar. Which linear inequality represents all the possible combinations of X pencils and Y rulers? Yeah, I hear you. We need to change the P and the R to X and Y. No problem. We'll get that. If Layla's spending limit is $25. Now, what is that saying? That's saying that she has $25 in her pocket. She could spend $1, $2, $3, all the way up to and including $25. So the correct inequality symbol is less than or equal to 25. All right, so 0.1x plus 0.5y less than or equal to 25. And that corresponds to answer choice A. Number two. The graph of 8x plus 4y equals 12 is shown below. Which ordered pair is in the solution set of 8x plus 4y less than or equal to 12? What? Well, here's what it's telling us. It's saying they have graphed the equation of a line. Okay? That equation happens to be identical to this linear inequality. And what it's saying is, first you have to shade the inequality correctly. You're going to be shading either above or below the line. And then you have to plot the ordered pairs to see which one of them is in the solution set. So the very first thing we have to do is figure out which way to shade this. The only way to know is to convert the equation of this inequality from standard form, which is it's the form that it's currently in, into slope-intercept form. So y by itself on the left, everything else on the right. My first step is to subtract 8x from both sides. On the left, the 8x's cancel, and I have 4y less than or equal to negative 8x plus 12. Every term is then divided by positive 4. On the left, the 4's cancel, leaving y by itself. Y is less than or equal to, and negative 8 divided by 4 is negative 2x, and then 12 divided by 4 is plus 3. So that is my linear inequality. That is in fact the same line, but now we're certain that that is in fact the correct inequality symbol. Now, let me ask you a question. Which direction am I going to shade? Am I going to shade above the line or below the line? Okay, very good. I'm going to shade below the line. So it's helpful to have a highlighter on hand something where you can kind of quickly color in. So it doesn't have to be an art project. You just want to show that we're shading below the line. All right? Now here comes the next part. It says which ordered pair is in the solution set. So all we're going to do here now is check these ordered pairs and see which one of them is in the solution set. First, let's check 0, 4. I start at the origin and I go up 4. So here is that first point, 0, 4. Is this point in the shaded region? No. So it can't be A. How about 3, 6? Starting at 0, go to the right 3, and then go up 6. So there's that point right there. Is that point in the shaded region? No, it can't be B. How about 4, 2? Okay, go over to 4 and go up 2. Is that in the shaded region? No. So we're pretty sure it's D, but let's check it anyway. Starting at the origin, go over 3 and then down 3. Now this is actually an interesting point. I am right on the line, but that's okay because it says less than or equal to. So less than or equal to, it's okay for me to be on the line. Therefore, the answer is D, 3, -3. Onward to the next problem. Number 3. Okay, number 3. Chef Cohen is planning to order beef needed to make hamburgers for his food truck restaurant. He contacted 6 beef suppliers and received the following estimates. Now, here it's useful to create a table. We need to create an L1 and an L2 table because we're going to put this into our calculator. And we need to write down 1, 2, 3, 4, 5, and 10, not 6, because we're talking about the price per pound of beef. These numbers here are irrelevant. They're just there to confuse you. All right, so 1 pound is 3.75, 2 pounds is 3, 3 pounds is 2.5, 4 pounds is 2, 5 pounds is 1.75, and 10 pounds is 0.5. All right, so what we're going to do now is get this into our calculator. So let me show my calculator if I can. Let me see if I can show that calculator. All right. So I can show that calculator. All right, let me pull that into the frame here. And now you should be, if you're watching this on YouTube, you should be looking at a digital representation of the calculator. Okay, so the very first thing I want to do is clear the memory. Second, plus 7, 1, 2. Reset the memory. And I will clear this key entry system here so you can follow along. What we want to do here is click Stat. Okay, and then once we get into Stat, we're going to click Enter on Edit. Now from this menu, for L1, referring to our table, we're going to put in 1, 2, 3, 4, 5, and 10. And then for L2, we'll put in 3.75, 3, 2.5, 2, 1.75, and 0.5. Okay, at this point, you've got this data into your calculator. You'll hit the Stat button again, right arrow 1 to Calc, and then choose option 4, linreg AX plus B. Hit Enter through these menus and enter one more time. And what you're given are these lengthy decimals. So what I'm going to write down is A equals negative 0.33934. And then B equals 3.6639. And I will exit the calculator view and get us back to our work surface. Okay, so all I did was I copied down the information from the calculator screen. And let's make something clear here. Under here it says note, use 3 significant digits for all calculated intermediate values. That means I need to focus my attention on these first 3 digits in the decimal and look at the next digit. If that is 5 or greater, I have to round the last of the 3 digits. It's not 5 or greater, so I don't have to round. But we are going to say this is equal to, or this becomes rather, negative 0.339. Okay, same thing for 3.66. Those are the first three significant digits. The next digit is a 3, so I don't have to round up. So this just becomes 3.66. Now, one thing that's important to note is A is the slope and B is the y-intercept. So we can actually write an equation for this line. Y equals mx plus b. Y equals slope x plus y-intercept. So y equals negative 0.339x plus 3.66. That is the equation of a line that represents this linear relationship. Okay, now we're going to flash back to our calculator view and we're actually going to plug it in. All right, and what we're going to do is we're going to find out what each pound of beef costs if we're going to buy 7 pounds of beef. So first let me show the calculator again. Okay, we're still on this other problem, or we're still on this part of the problem. So just go to y equals. Go to y equals. And what we're going to put in is that equation we wrote down with the truncated values, the 3 significant digits. So y equals negative 0.339x plus 3.66. All right, so it'd be interesting. Let's graph that. Okay, a downward sloping line. It represents a negative linear relationship. So as y goes down, as the price of beef goes down, the quantity of beef goes up. Same thing as the price of beef goes up, the quantity of beef goes down. Negative linear relationship. It's also called an inverse relationship. So who cares, right? Well, what we were looking for was 7 pounds of beef. So hit second key and then graph. And we're really looking for the y value when x is 7. Okay, so we're going to write that y value down, 1.287. And then we're done with that, so we'll go back to our paper view. And again, we're going to need to round to 3 significant digits. So here, 1.28, next digit is 5 or greater, so I'm going to round the 8 to a 9. So this is going to become 1.29. All right. So now the snake in the grass here is that 1.29 is an answer choice. But this is incorrect because that is $1.29 per pound of beef. And it says here, what is the best estimate of the total cost? I highly recommend either underlining or putting a circle around the words total cost of 7 pounds of beef. So what we would do is take $1.29 per pound, just like at the grocery store, okay, and multiply that times the number of pounds that we want. And $1.29 per pound times 7 pounds equals $9.03. All right, 9.03. And so that answer choice is A. Number 4. The following data were gathered from the graphs of lines J and M. And then it gives us all this data, okay? So the most important thing to know is that we need to create an L1 and an L2. So we're creating an L1 and an L2 for two different lines, one for J and one for M. So we're actually going to be doing this whole process twice. So for J, we're going to have L1 representing X data and L2 representing Y data. And then for M, we'll have L1 representing X data and L2 representing Y data. And we'll make a little table here. All right. And the X values that were given for J are -9, -3, and +2. The Y values given for J are 0, 18, and 33. The X values given for M are -4, 0, and 10. The Y values given for M are 10, 8, and 3. Okay, so we're going to need to put both of these into our stat edit stat calc linreg ax plus b sequence in order to find out the equations of these two lines. So we'll do that. We'll show the calculator again. And this time I will probably need to clear my memory. Second plus 7, 1, 2. Just clear the memory out, make sure we don't have any extra data hanging around there. And we're going to click Stat and enter on Edit. We'll put in that data from J, -9, enter, -3, enter, and 2, enter. Then for the Y values, we will put in 0, enter, 18, enter, and 33, enter. Okay, and then it's going to be stat calc linreg ax plus b, and it gives us this equation. So if we're reading this, y equals ax plus b, then y equals 3x plus 27. Right, I've written that down on the paper, but we'll just continue. We'll go back to stat and click on edit again, and there's a trick we can do. We can just overwrite the existing data. So we can just put in here for this. Now we're putting in the M data. So those X values for M were -4, enter, 0, enter, and 10, enter. See how it just overwrites the data? And then we'll go over to L2 and put in 10, enter, 8, enter, and 3, enter. Stat calc linreg ax plus b. And for this one, we were given y equals -0.5 plus 8. Right, so now we'll flash back to our work surface. And we have our two equations. Now there's some problems with these equations. The main problem is that they are in slope-intercept form, and all of our answer choices are in standard form. So we're going to need to convert these into standard form. It's not that hard. We'll start with the J one. So we'll subtract 3x from both sides. Remember, my goal is to get ax plus by equals c, where a, b, and c are whole numbers, and a is a positive number. So first I'll subtract 3x from both sides, and that will give me -3x plus y equals 27. Now there's only one problem with this, and that is the negative 3. We want that to be positive 3, so put parentheses around the entire equation and multiply everything by negative 1. When you do that, you will change all of the signs. Okay, so this will just become 3x minus y equals negative 27. All right, so that's the standard form of J. Now let's do the standard form for M. The first thing we need to do is, oops, I forgot to write the x there. The first thing we need to do is change the decimal to a fraction. Okay, so first thing we'll do is we're going to rewrite this as y equals negative 1/2 x plus 8. And now I'm going to convert this to standard form by adding 1/2 x to both sides. Okay, on the right they cancel out. They cancel out over here as well. So on the right they cancel out, leaving 1/2 x plus y equals 8. Now, is this in standard form? Drum roll, no. It's not in standard form because the leading coefficient is a fraction. Remember, standard form, a, b, and c are whole numbers, and a is positive. So put the whole thing in parentheses and multiply every term in the equation by 2/1. And that will eliminate the fraction in the first position, leaving just x. And then 2 times y is plus 2y equals 2 times 8 is 16. So now I have x plus 2y equals 16. Those are my two equations, and so I'll say that the system of equations is 3x minus y equals negative 27, and x plus 2y equals 16. All right, so that's my system, and I just need to find which answer choice matches that. Wow, it's C. All right, so that's how you do number 4. On to number 5. This one will be faster. The graph of the quadratic function r is shown below. If k of x equals negative x squared and r of x equals k of x plus n, what is the value of n? So here, distinction number 1. This is the graph of r of x. That's what's graphed currently. So what it says is r of x is equal to k of x plus n. Well, what is k of x? Well, thankfully they tell us k of x is negative x squared. So we're going to be playing a substitution game. So now we're back to r of x equals negative x squared plus n. Well, it sure would be helpful to know what negative x squared looks like, so I might be able to figure out what n is. All right, so back to the calculator real quick. And what I'm going to do is go to y equals and type in negative x squared. Okay, I'm just going to graph it. So what I'm seeing an upside down x squared graph. All right, it hits the origin, but it points down. So while you're looking at that, I'm going to sketch that in red pen on my physical graph, and then we'll flash back and take a look at it. So let me flash back to the work surface. And you see I've drawn in x squared, or negative x squared. Okay? So the question is, what happened to this graph? It moved up. That's all that happened. This whole thing just moved up. So that we want to look at the distance between these y-intercepts. What is the distance between those y-intercepts? Well, this is 0. So 1, 2, 3, 4, 5. it went up by 5. I'm going to say it shifted up plus 5. All right, so what does that mean? That means that n is 5. So the full expression r of x equals negative x squared plus 5. Okay, that's how you do number 5. And so n is 5, so that's A. Number 6, what is the correlation coefficient R for any data set if all the points reside exactly on a line with slope m is greater than 0? Well, this is just confusing language. What is being asked of you is to imagine a plot that looks like this, a data plot that looks like this. Okay, what would be the R value? What would be the correlation coefficient if I tried to fit a line to those data points? Well, all of them would lie right on the line. Right, so I'll show you how this works on your calculator so you can prove it to yourself. On your calculator, if you go to Mode and you go and turn Stat Diagnostics on, so that was Mode, let's do it again, Mode, all the way down to Stat Diagnostics. And turn Stat Diagnostics on. Okay, then hit Stat and Edit. This time we want to clear out this data. So go hover over L1 and hit Clear, Enter, and then go up, right, hover over L2 and hit Clear. Don't hit Delete, and then hit Enter. Now these are cleared out. So go back to L1 and we'll put in some points like this. So 1, 2, 3, 4, 5, 6. And then for L2, just put in 1, 2, 3, 4, 5, 6. Okay, now go to y equals, delete this thing out of here, or clear it out of here. We don't want anything in there. And then go turn on plot 1. Okay, turn that on by up arrow, hover over plot 1 and hit enter. Then hit graph. So there I've actually kind of created in the calculator exactly what I drew on the paper. Okay, so now that you've looked at that, go back to Stat. Now go to Calc and click on linreg ax plus b, so option 4. Enter through the menus. And it says here y equals 1x plus 0. Okay. But look what else joined the party. R squared and r. Notice that the r value is 1. So what I'll do is my equation ax plus b is y equals 1x plus 0. Okay, aka y equals x. So let's just go back to y equals and put in there x. All right. And now graph again. Now do you see how that line went right through all those data points? What that's telling me is that my model is a perfect fit for the data points. And that is evidenced by the fact that the R value, or the correlation coefficient, is perfectly 1. Okay. So, and I want to show you how this thing could get messed up. So it wouldn't be 1 if the data didn't all fall in a line like that. So let me just change this to 5. And let me change this to, I don't know, 8. Just kind of mess the data up a little bit. Okay, now let me graph this. Okay, now that line that I drew doesn't fit the data correctly. Okay, and that's because everything changed when I changed my data. Let me go back to Calc and hit 4, enter through this menus, and you'll see that that R value fell below 1. Okay, now r is only 0.662. And look, everything changed. My y-intercept changed, and my slope changed, and my y-intercept changed. So changing that data changes the r value. But here's the long and the short of it. When I'm looking at this graph, I cannot put a single line, straight line, through all those points. So my r value would be less than 1. But in the problem we have on the test, it's saying that all the points lie on the same line. So in that case, the r value would be 1. Okay? So that was kind of a digression on the correlation coefficient statistics. But the answer is D. Number 7. Write the linear inequality 3 open paren negative y minus 6 close paren greater than or equal to 4 open paren 3x minus 15 close paren in standard form ax plus by equals c. Okay, so what we're going to do is we're going to write down what we were given. 3 open paren negative y minus 6 close paren greater than or equal to 4 open paren 3x minus 15 close paren. Now I will distribute the negative 3 or the 3 and the 4 through their parenthetical expressions. So I'll have negative 3y minus 18 greater than or equal to 12x minus 60. Okay, so now I'll add 18 to both sides. On the left they cancel, leaving negative 3y, okay, greater than or equal to 12x minus 42. Now I'm going to have to bring this guy up here to do the next step, which is to divide everything by negative 3. Now alert, we're going to divide by negative 3, so we're going to have to flip the sign. So now I've got negative 3y divided by negative 3. Instead of greater than or equal to, we'll do less than or equal to 12x divided by negative 3. Okay, minus 42 divided by negative 3. Okay, fair enough. The negative 3's cancel on the left, leaving y by itself. We flip the sign so it's less than or equal to. 12 divided by negative 3 is negative 4. X. And then negative 42 divided by negative 3 gives me positive 14. Okay, now this is in slope-intercept form. I want this in standard form, so I'm going to add 4x to both sides to move the x term to the left side of the equation, or the inequality. So on the right, those cancel out. And what I'm left with here, just to move this up one more time, is 4x plus y less than or equal to 14. And that corresponds to answer choice C. Okay, let's do one more here. Julia makes hand-sewn teddy bears and packs them in shipping containers that can each hold 25 teddy bears. Julia removes 12 teddy bears from one of the containers before shipping all the bears. Which function below shows the relationship between y, the total number of teddy bears, and x, the total number of shipping containers? All right, this is one of those questions. Harder. It sounds harder than it is. Okay, so let's just write down the information we're given in the order we're given it. I have 25 bears can go into one shipping container. Okay, so there's a shipping container. 25 can go into one of those, but Julia removed 12 before she shipped them out. So if this is, consider this to be a variable like x, then y equals 25x minus 12. And it just isn't any more complicated than that. So that's answer choice D. Okay, next. Okay, number 9. Ben and Shauna are raising money for their agricultural science field trip by selling different types of meats from a catalog. Ben sold 18 boxes of venison jerky and 13 boxes of smoked ham. Shauna sold 3 boxes of venison jerky and 38 boxes of smoked ham. Ben and Shauna raised exactly the same amount of money for a combined total of $1,290. Find the cost of 1 box of venison jerky and the cost of 1 box of smoked ham. Oh, brother. Well, this is a systems of equations problem, and it helps us if we will write down our little structure that we learned. So we got B for Ben and S for Shauna, and we'll make our line box plus line box equals line, and then line box plus line box equals line. And it's more of a game of let's fill this information in. So we know that they sold venison. We'll put V for venison and H for ham. Well, how many boxes of venison did Ben sell? 18. How many boxes of ham? 13. Shauna sold 3 boxes of venison and 38 boxes of ham. Now this is the hard part for this question. It says they raised Ben and Shauna, Ben plus Shauna, raised the total of $1,290. And it says they each raised the same amount of money. So if I divide $1,290 by 2, I'll get what they each raised, which $1,290 divided by 2 is $645. So Ben raised $645 and Shauna raised $645. Okay? So now, instead of trying to solve this ridiculously complex system by hand, I mean, it's not that complex. We could solve by elimination by multiplying every term down here by 6, because then we would be able to eliminate the V term. That's the old school way of doing it. Many of you like to do the matrix method, so that's the method I'm going to show here. We're just going to fill in our 2 by 3 matrix box. Okay, so in the top left I'm going to put 18, then 13, and 645. Bottom row 3, 38, and 645. And that's what I'm going to put into my matrix editor on the calculator, which is where we're headed next. All right. So from the matrix editor, how do we get to the matrix editor? Well, you hit the second key, and then down here you hit this x to the -1 key, or matrix. Now you're in the matrix menu, and we're going to right arrow over to edit, and then we will edit the matrix editor. Okay. Hang on 1 second for me. All right. So I think we are good. So we're back in our matrix editor, and what we are going to do is enter a 2 by 3 matrix. Okay, so we're going to enter a 2 by 3 matrix, and the data we're going to put in there is 18, enter, 13, enter, 645, enter, 3, enter, 38, enter, 645, enter. All right, from this menu, we will get out of here by hitting second and mode to quit. Now we're back on the home screen. Hit second matrix again, right arrow 1 time, and then scroll down until you are on the menu R for RREF. Reduced row echelon form. And that's going to be below the bottom of the screen. You have to go down to RREF. Okay, and once that's pasted there, you then hit second matrix again, and you're on where you need to be. You're going to grab that array and paste it there, and then hit enter one more time, and it's going to compute the results. So I'm going to write this down: 1, 0, 25 and 0, 1, 15. Okay, and we'll see what this stuff means here in a second. Let me get back to our work surface. Okay, so here is the work surface. And what I've done is I've just written down those results. Now it's important here to understand how to interpret this. So let's circle the V and the H, and then circle this one and this one. Draw a little line between the V and the H and between these two ones. Okay, this top left one is the V price, and the bottom right one is the H price. So in other words, venison cost $25 and ham cost $15. So which one of those choices that we have here correspond to this information? Well, it would be choice A. And that's how we solve number 9. Okay, on to number 10. What is the domain of the shaded region of the system of quadratic inequalities graph below? Oh boy, that sounds complicated. It really isn't. Now, one quick thing. The video resolution here is just not quite good enough to make it clear that that is an open circle. Okay? That is an open circle. I want to make that crystal clear. Okay? So I'm just going to use some with this whiteout stuff, and then I'm going to draw in this huge open circle right here, and make sure you know that this is -2. Okay, now we can kind of do our analysis. I'm going to move this up a little bit. Here's how I want you to do this. If you're not already sure what the domain is, I want you to first write off to the side a little note to yourself. Domain is X. Okay, so we're only interested in the X values. We want to see what's going on this way, not up and down. So we're going to look at this. Draw yourself a straight number line, just like this. Label it X axis. So we're just zooming in on the X axis. Alright, so on the X axis we have here in the middle 0, and over here we have -2, and right here we have 1. Now at -2 there is an open circle, and at 1 there is a closed circle. Okay? And in between is the domain, the shaded region. Okay? So that is our, we need to write that out as an inequality. And how the heck do we do that? Well, here's how you do it. Because that's an open circle, we're going to write -2 is less than X, and then because 1 is a closed circle, we'll put less than equal to 1. Okay, and that is, ladies and gentlemen, that is the domain of our quadratic inequality. And that corresponds to answer choice B. Okay, number 11. What is the equation for the horizontal asymptote for the exponential function in the graph shown below? Everybody take your pen or pencil or highlighter or signal flare or whatever you're using and put a box around the word horizontal. Okay, because one thing we are not interested in is this. That's a vertical line. So we're, zoom in and focus in on this dotted line. That's the asymptote line. Okay, so here's the exponential function. It's solid. Then you got this dashed line. That's the asymptote line. And the asymptote is this kind of guide mark below which the function will never go. Okay, so what is the equation for this line? Y equals mx plus b. Okay, what is the y-intercept of this dotted line? Well, if we look carefully, it's at 2. Okay, what is the slope of a perfectly flat horizontal line? The slope is 0. So here we're going to put in y equals 0 x plus 2. So 0 times x is going to still be 0. So we'll write y equals 2 because that 0x cancels out. So we're going to choose y equals 2 as our equation of our asymptote, which is answer choice C. Okay, number 12. Given the following values for x and f of x, compute the slope m, the negative reciprocal slope negative m raised to the negative 1, and the y-intercept b. Then write the equation of a perpendicular line with the same y-intercept. And here's the data that you're given. You are given, and I'm going to make, while we're reading this, I'm going to make a little L1 and L2 chart. L1 is x, L2 is y. Alright, so the data that I'm going to put in these fields is for x it's 3, 5, and 9. Got that here. And for f of x, or y, it's 19, 27, and 43. Okay? So that's what I'm going to put into stat edit stat calc linreg ax plus b. So let me get back to the calculator and go to stat edit. Okay, I'm going to need to clear these registers out. You could also clear the memory. Either way. And I'll put in here 3, 5, 9, and 19, 27, 43. Okay, and then I'll hit stat, calc, linreg ax plus b, and enter through my menu system. Okay, and there it gives me the equation of a line. I'm going to write this down. Y equals 4x plus 7. 7 is the y-intercept. Okay, we don't need this R2 and R1 data here. So let me flash back to my work surface. And I've written down the equation that I just pulled off that linear regression calculator. So, looking at this slope-intercept form equation of the line, what is m? M is 4. So m equals 4. Now, if m equals 4, ladies and gentlemen, what is the negative reciprocal of 4? That's how you write negative reciprocal. The negative reciprocal of 4 is negative 1 over 4. So the negative reciprocal is 1 over 4. That is the slope of a perpendicular line to a line that has a slope of 4. That perpendicular line to a line that has a slope of 4 is negative 1/4. That's the slope of the perpendicular line. Well, what is the y-intercept of the perpendicular line? It's still 7 because it said the same y-intercept. So if I'm going to write an equation for the perpendicular line, I will write y equals negative 1/4 x plus 7. So what I need is to find this data, and this data all in one problem. Let's see, A, okay, wrong slope, wrong, everything's wrong. B, okay, incorrect slope, incorrect reciprocal, negative reciprocal slope. C, correct slope, correct negative reciprocal slope, correct y-intercept. and correct equation of the perpendicular line? The answer is C. All right, moving on. These get a little faster as we move on. Okay, given y equals 8x minus 3, what is the domain if the range is 13, 29, 37, and 45? Okay, what's going on here is they're giving us the y values and they're asking us to find the corresponding x values. So make yourself a little L1 and L2 table where L1 is for y and, or sorry, L1 is for x and L2 is for y. And we're going to put in the data we know. And what do we know? We know the range values. So actually, should probably just take a moment here to put a circle around range and make a note. That's the y values, or the f of x values. And the domain, those are the x values. Okay, so we're given the range values, which we're plugging in here now. 13, 29, 37, and 45. So this is kind of the output of the function. We need to know the inputs. And this is the function here, 8x minus 3. And that's what we're going to put into our calculator. So we'll show our calculator now. You don't have to do it this way. You can solve it by hand, but most students want to use the calculator. So here we're going to put in 8x minus 3. And then we'll hit second graph. What we're looking for, usually we're looking for x values. Now we're looking for y values. So when y is 13, what is x? X is 2. When y is 29, x is 4. When y is 37, x is 5. When y is 45, x is 6. So let me flash back to my work surface here. Okay, so I've written those in now. So I've written in the domain. This is the domain. Okay, now I'm going to turn it 90 degrees to the right. Say, well, the x values of the domain are 2, 4, 5, and 6. That's it. Okay, that is the domain when the range is this discrete set of information. And that corresponds to option D. Number 14, write an equation of the line that passes through -3, 7 and 12, 10 in slope-intercept form. There's a real quick and easy way to do this. You're going to make a very simple L1, L2 table. And you'll put in -3 and 12 for your x values, because this is your x values, x1 and x2. And this is your y values, y1 and y2. So we'll put in -3 and 12 for x, and then for y, we'll put in 7 and 10. Okay, now if you want to, real quick, and this is, I guess, what we'll do here, we'll flash back to the calculator. Flash back to the calculator and go to Stat, Edit. Okay, we're going to, I guess, clear these out. And we'll put in -3, enter, 12, enter, up, up, right, 7, enter, 10, oops, 10, enter. Then hit Stat, Calc, Linreg, AX plus B, and just cycle through the menu until you compute the equation of the line. Okay, A equals 0.2 and B equals 7.6. Now, I don't know if you noticed this when we were looking at our answer choices, but they're all in improper fractions, fraction form. So before we flash back to our home screen, or our work surface, let's go to our home screen by hitting second quit, and we'll type in 0.2, enter, and then math frac, enter. And that turns 0.2 into 1/5. So that's the slope. The slope is 1/5. Now we'll do the same thing for 7.6. So 7.6 is an improper fraction, is 38/5. So now I'll flash back to our work surface. So I've written this out, and I need to just finish writing y equals 1/5 x plus 38/5. Now there is a way to do this by hand. You know, I've shown it in other videos, but because we're really trying to work quickly here, I'm just going to leave it at that. This is answer choice, looks like D, answer choice D. Number 15, if f of x equals x squared plus 2x plus 27 and f of x equals 30, what is the positive value of x if it exists? This is a factoring problem. But the first thing you have to remember is that it says f of x, and then it equals something, and then it says f of x, and then it equals something different. Okay, so what we have to do is write f of x equals f of x. Okay, wow, big surprise. I'm so shocked that f of x equals f of x. But what that means is that we can set the things that f of x is equal to each other. So if f of x equals f of x, then x squared plus 2x plus 27 equals 30. Okay, that's interesting. Well, if we want to factor this, we need to get this thing in what's called standard quadratic form, which is ax squared plus bx plus c equals 0. Right now it equals 30. So I want to get rid of that 30 and leave a 0 on the right. In order to do that, I'll subtract 30 from both sides. Okay, 30 minus 30 on the right makes that 0. And then 27 minus 30 makes that -3. So this becomes x squared plus 2x minus 3 equals 0. And I can factor this. All right, I'm going to end up with two factors. Okay, and we already know the leading term is going to be x because there's no leading coefficient here. So the first term is going to be x. Now to find the second term, we need two numbers that add together to give positive 2 and who multiply together to give -3. So we go over here and write -3 and make our little factor tree. Say, how about -3 and 1? Okay, those multiply together to be -3, but they add together to be -2. We wanted positive 2. So how about -1 and positive 3? Multiply together to give -3, add together to give positive 2. That's what I wanted, so these are my factors. Right? We'll just check that. -1 and 3 gives positive 2. -1 and 3 gives -3 when multiplied. So over here we'll write x minus 1 and x plus 3. Now these are the factors of the quadratic, not the zeros, not the values, not the solutions. So what we have to do is, I'm going to kind of run out of space here. Let me make a little space here. Okay, I'm going to work this problem up in this blank space up here. I'll write down my factors x plus 1 and x minus 3. Sorry, x, messed up. X minus 1, x minus 1, and x plus 3, and set those both equal to 0, and then solve for x. So you add 1 to both sides here, and x equals 1. And then here you're going to subtract 3 from both sides, so x equals -3. All right, now remember what the question asks. What positive value of x? So we're going to just take we're only interested in the positive value of x, and that is 1. and that's answer choice C. All right, that was a bit of a challenging problem. Number 16, what are the zeros of this quadratic function? We can solve this in literally 1 second. Take your pen or pencil and circle the places where this graph crosses the x-axis. Okay, at -3, 0, and 2, 0. All right, it's as simple as that. And the answer choice corresponds with D. Okay, that was number 16, and that was super fast. All right, on to number 17. We're really, really close. I can feel I can see the end in sight. Last page. And some of these are real easy. How do you find the y-intercept B of an equation passing through a given coordinate pair after you have created the equation using the point-slope formula? So, how do you find the y-intercept B of an equation passing through a given coordinate pair? Well, the way you find the y-intercept is you set x equal to 0. So let's look. Substitute 0 for y. Nope, don't want to do that. Look where the equation passes the x-axis. Nope, don't care about that. Substitute 0 for x and solve for y. Absolutely, that's what we do. The given y-coordinate is the y-intercept. Okay, that is a common mistake. That's not true. So it's B. All right, on to number 18. What is the x-intercept of the linear equation 6x minus 3y equals 18? Okay, now there's a real simple way to do this. Okay, remember, we're trying to find the x-intercept here. So we're trying to find what is x when y is 0. Watch this. 6x minus 3y equals 18. Okay? Well, I want to know what x is when y is 0. So why don't I just substitute in a 0 for the y? Oh, that's 0 times -3 would just make that whole thing 0. And now I have 6x equals 18. Now it's pretty simple. Divide both sides by 6, and x equals 3. Guys, it was that simple. What did that take? 10 seconds? So that's the x-intercept is 3, 0. That's D. Number 19. If f of x equals x squared, what is 2f of x? Okay, this is another problem that looks harder than it is. It's saying if f of x equals x squared, what is 2 times x squared? Well, ladies and gentlemen, brothers and sisters, comrades and friends, fellow countrymen, it is simply 2x squared. All right? Bit of a letdown, right? You thought it was going to be harder. It's easy. Number 20. Using your calculator, oh brother, calculate the correlation coefficient R to 2 significant digits using the statistical plot given in the graph below. Okay, then it goes through all the steps to turn on the statistical diagnostics. Well, here's what we're going to do. Here is what we're going to do. We are going to make ourselves an L1x and L2R, L2y table. We're going to plot all these points in and then put them into stat edit, stat calc, linreg, and take a look at the R data. Okay, the hardest part is to actually take these dots and convert them into coordinates. So let's take this dot right here. That first dot right there, that's at 1, 1. 1, 1. Okay, the next 3 dots all have an x value of 2, so I'll try to simplify, save some time. And their associated y values, 2, 0, 2, 1, 2, 2, so 0, 1, 2. Okay, the next values, all the 3 values have an x of 3, and their y's are 3, 1, 3, 2, 3, 3. The next 3 values all have an x of 4, okay, and their y values are 4, 3, 4, 4, and 4, 5. Okay, the next 2 values have an x of 5, and the y's are 4 and 6, and then the final value has an x of 6 and a y of 5. Boy, that looks like a lot of data. It's actually not that much. You know, all we're going to do now is just stick it into stat edit and we'll be done with the entire test. Okay, so let me transition back to my calculator and go to Stat, Edit. Okay. Oh, I want to make sure I've got Statistical Diagnostics turned on. So let's go to Mode. Okay, I want to make sure everybody understands how to do this. So first I'm going to clear all my memory. Second plus 7, 1, 2. So let's assume you're starting from a hard reset. Okay, you're just sitting at this window. Click Mode and go down until you're on Stat Diagnostics. Okay, for some reason the computer is just hanging on every single line. Could go to Stat Diagnostics and hover over On and hit Enter. Okay. Now we've got Stat Diagnostics on. Click on Stat and then Edit. Now I'm going to just type in the information that I had from the chart that we made. 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 6. I'll go all the way back up to the top and do the same thing for L2. 1, 0, 1, 2, 1, 2, 3, 3, 4, 4, 4, 6, 5. Okay, so we got all the data entered now, and we'll click on Stat, Calc, LinReg AX plus B, and cycle through the menus. And here we've come to our statistical information, R. We're looking for R. And I'm going to write this down. R equals 0.87609. Should be enough. Okay, that's all I need to do this problem, because I'm trying to find the correlation coefficient, and that's the R value. So we'll go back to our work surface here and transition back. And just notice one thing. It says here we need to round this to 2 significant digits. Okay, 2 significant digits. And right now I've written down 5 significant digits. So I need to look at the first 2 digits and ask myself, based on the next digit, do I need to round up? Yes, because if it's 5 or greater, I need to round up. So R is equal to point. I think I might have input something wrong. I think I might have entered some data incorrectly here. Let me make sure. 1 comma 1, 2 comma 0, 1, 2, 3 comma 1, 2 and 3, 4 comma 3, 4, and aha, there was my error. I put an extra, this should have been a 5. All right, let me go correct that. It's good we caught it. See, that little tiny difference makes all the difference. So we're going to go fix that. That was the second 4 that I put. Needs to be a, so this 3, 4, 3, 4, and 5. Okay, so 3, 4, and 5. That needs to be a 5. All right, so now we'll do Stat, Calc, LinReg, AX plus B. Sorry for the mistake. There, that's better. So I'm going to white out the mistake I made and write the correct correlation coefficient, which was 0.8588. All right, now we'll go back to our work surface. Mistakes happen. And again, we're rounding to 2 significant digits, so we're really focused on these first 2 digits. Looking at that next digit's an 8, I've got to round that 5 up to a 6, so it's 0.86, right, which corresponds to answer choice B. Now we have done it. We have completed all 20 questions of this test, and we are finished. Thank you so much for watching. Please make sure to like and subscribe, and hit that notification bell so you always receive a message when I make a new video.